going to start hitting you with Python now. Third new thing for the day, right? Hope your brains aren't dripping out of your ears too much. So, for starters, let's open a terminal. So Python is an interpreted language, and by that I mean there's a program called Python that will run scripts and do things for you. Python also has, if you just call Python command line, it will open up an interactive prompt. And so all of you should do this, type this along with me. And so you can type in line by line. Right, everyone's favorite first program. You can assign variables, and print them, and all this sort of works. Realistically, you're not going to want to type out entire programs at the command prompt, because that's a lot of work, and you're going to make mistakes, and it's good to do something with that. So instead, we're going to use something called the IPython Notebook, which is an HTML interface to a Python interpreter that is, in my opinion, much more convenient to use. It's great for teaching and really, really convenient for doing data analysis stuff. It does things like tab completion, right, which is the second greatest thing in the world, version control being the first. So we can quit out of this. Okay. And so let's go to lessons. So starting from the repo that you guys downloaded earlier, go to lessons, Python, and there should be some stuff, some of these files named .ipynb, and type the command IPython. IPython is a different interpreter that has some nice features like tab completion and nope. And so this should print some stuff to the screen and then launch your web browser. So you should see stuff that looks kind of like that. Something about serving a notebook and whatever. And then show you a website that looks sort of like this. Good? And so all of you seem like really sharp people, so we're actually going to jump straight to the first round of it. So,
quick question: when you
got it? Good.
Is this IPython notebook just show up? Or,
So
I'm running slower.
It's still thinking.
Yeah.
Give it a minute. So everyone made it to this dashboard screen.
Yeah, just made the lesson.
Okay. So
Can you put the path to lessons? I screwed that up.
yes.
Someplace else.
So I'm in it. So you go to 20. So the repo we had you clone at the very beginning.
Yeah.
So it should be 2013-09-06, right? And there's this stuff. Go to lessons, Python. There. And then type IPython notebook. Yep.
Can you change directories in the notebook, or do you have to do that term?
Nope, you have to start a new notebook server in each directory.
Yeah, that's
feature's
the problem.
coming.
Once I finally got it up, I realized I was but
So you have to get to that right directory, fire it up. So, and once you get here, I want you to click on this vars types exercises. It'll give you the scary looking screen which just says you have a newer version of the notebook and it's been automatically converted. So you should see something that looks like this. Okay? Okay, so we're in the notebook. What the notebook is a very convenient graphical interface to Python terminal that's existing under the covers. And so you can still type in commands interactively. So for this first exercise, it says assign variables with values of these different things, right? So please type this along with me. So this should be vars types exercises. Please open that notebook. She'll give you this. So you just start typing 1 equals 1. Very clever. And then to execute this cell, so the notebook is divided into cells of self-contained code that you can execute and they get sent. The kernel, and then I'll go back with it. And so you execute a cell by using Shift-Enter. And we then ask it to print 1. And Shift-Enter again, it'll print. And if you come down here and print 1, these things exist between different cells. And you can see that this in 1, in open bracket 2, and then bracket 3 tells you the order in which things were executed, which can be handy if you start doing weird things in different orders. In general, I recommend start at the top of the page and work your way down. Don't cycle around because it becomes really hard to keep track of what's going on. So, coming back to Python, you've hopefully typed in a couple simple Python statements at this point. You've taken an integer 1 and you've given it the name 1. You use the print statement to print a variable, and you can see it returns back the thing you'd sort of expect. Python syntax is pretty simple. You have the thing on the right side is assigned to a name on the left. Everyone comfortable with this sort of general syntax? This should be R, C, most things. No Lisp weenies in the back. Okay. So, with that in mind, one other thing to know is Python, you can define strings with quotes.
Thank you.
And Python doesn't care about what kind of quotes you do. Everything works. So, do the first exercise. Right, you should have something that looks sort of like this. Right? Let's go back and change this 5, be 5 dot. Give it a decimal point. So Python is a language, can be called strongly typed, which means that all variables have a type and they don't magically become other things in different contexts. So I'll unpack that in a bit, but we can ask a variable what its type is. Let's print the type of 1. What do you think this is going to give you back? Very clever. So it's an int. An integer, right? We know that integers from math class. They're 1 and 2 and 3 and -5. Python has fairly intelligent ints. So if you had a big int with a whole gazillion zeros, that if you've ever had to worry about floating point precision, you would be seeing this in About to Cry. But Python will handle that just fine. So what is our type for 5? Any takers? Float. So we know what floats are. So floats are floating point precision numbers. These are numbers that have a decimal and a fractional part, and usually some exponential. They have finite precision, which means you can only get about 16 digits of precision, which is plenty for most cases, but there's finite precision. So if you try and add 1 plus 1e to the 30, right? It's just 1e to the 30. Right, because it can't represent that 30th digit. There just aren't enough pieces there. Finally, what's the type of 10? Probably guessed it's a string. So strings are strings of characters in Python. Right, this is like text, right? You know what text is. So now that we have an int, a float, and a string, let's try and combine them, right? So Python has normal syntax. If you want to multiply numbers, you would do that's valid syntax. So try a bunch of these and see what comes out. So you can try, let's do 1 times 1, gives you 1. So try a bunch of combinations of these and see what happens. Maybe even ask the types that come out of that. Hopefully poked at a couple of these. Something you may have noticed, that when you multiply ints, you get ints back, just like you'd expect. You multiply ints and floats, you get floats back. You multiply an int and a string, you get another string. So that's interesting. What's going on there? So let's say we want to do 4 times 10. So for strings, what does it mean to have 4 times a string, right? Well, coercing 10 to be the number 10 sounds like crazy, because then all kinds of weird things would happen. You have numbers turning floats and just cats and dogs sleeping together crazy, right? So the most sensible thing to do with multiplying strings is to just make 10 strings and just glue them together, right? So these are the kind of operations you should expect. So some of these may not have worked, right? So 5 times 10 freaks out, right? What does it mean to multiply a floating point times a string? I don't know what that means. And so now we see that the first case of the Python interpreter giving you an error. It's raising an exception, which means I've encountered some sort of weird behavior that I don't know how to deal with. When you start developing Python, you'll see these all the time because we make mistakes. These are bugs. And so the error message is relatively convenient. That's a type error. I can't multiply a sequence which I guess is this 10 thing. It's a sequence of characters, but type non-int, type float. So it's saying that 5 is not an int, and 10 is this sequence thing, and I don't know how to make those two interact. One question. Okay. Basic types are good. Python has a small core language with lots of cool things in the standard library that you have to pull in explicitly. So if you're used to like a MATLAB kind of environment where it's very geared at doing linear algebra and you have all kinds of stuff dealing with arrays and a very scientific oriented workflow, you'll be a little disappointed because these are not present. You should think of Python as a general purpose language with great domain-specific libraries. So people write web servers in Python. YouTube is run on Python. The server serving this is in Python. There's a little JavaScript on top. But then you also have supercomputers that are run in Python. So that huge breadth would be really hard to maintain. Yet you put everything in the same place. And so let's import math. Everyone, please type this alone. And then we will see another instance of the second greatest thing in the world, is tab completion. So now that we've imported math, IPython, so math is now a defined variable, and math can have attributes, can have things that are attached to it. So things like the cosine function, right? Because we always want to take cosines of things, right? That's what scientists do or something. And we can take cosine of 3, and it works. And so, but the thing I really want you to see from this is first that there is a standard library module called math, and you can import these you can get access to the goodies in math by importing it. And then this IPython notebook thing will help you tab. And so that means it makes it really easy to find and discover the thing you're looking for. So super another thing is Python. So getting at this idea of objects having attributes. Python is an object-oriented language, which means that variables can have attributes. So 1, remember, is a type int. It's 1. 1 has a few things you can ask, right? I don't know why you'd want the imaginary component of 1, but it's 0. But you can see that if we're complex, this might be something useful. So do the next couple exercises. Type through them. They're pretty simple. And I'll pick things back up in a second. So hopefully you've poked around these things a little bit. So math question for you, pop quiz. What's the log of the negative number?
Not defined.
Right. Right, it's not defined. And so if you try and ask these math questions to do something that makes no sense, it'll yell at you, give you a value. Right? Good. Right? These are the sort of things you would like. You would rather errors to not pass silently. Right? If you do something that's a bad idea, you don't want it to just give you nan and continue on happily, because nan is not a number will propagate, and then pretty soon your whole simulation is just multiplying nans and adding nans equaling more nans. And an entire name is just ruined to a generation. So, right, errors should not follow silence. This is also sort of the philosophy behind Python. That if you break something, it should yell at you. Dividing by 0 will yell at you, which is occasionally a quick and dirty way to make a program die right here. So let's do one more. Okay, let's finish these real quick, and then we'll give you caffeine. So Python has a few defined helper functions. So there's one called len, which is probably appropriately defined. So if we ask for the length of 10, remember what 10 is? Remember 10 is a string. It would give you 3, right? Right answer. Yeah, let's basic thing. So okay, so we have super basic types. Python has ints and floats and the stuff you'd expect. Python also has lists. It has container types. So cool thing about Python lists is that they can have anything, and if you come from a compiled language, usually if you have a list, you can only have types. You can only have things of the same type. So they can all be floats, they can all be ints, but you can't mix ints and strings and whatever. Python is super high level. It doesn't care. You can stuff anything you want. And so in this particular case, just execute the example, and you can make a Python list, right? What do you think the length of the list should be? List, right? Again, no surprises, pretty familiar. You can do things with lists, like append to them, right? So we can append 3, print it, and now 3's there. Right, we can modify these. We can extend them. We can pop the last element, make it one shorter. We wanted to see all the things we can do with Python lists. We can tab complete to see all the things. We can reverse it, sort it, append, and ask how many things are in there. Extend would Python would list extend. So if you have another list, so if instead of appending one element at a time, you wanted to take another sequence, another list, and just slap it on the end, that's what extend does. Yeah. Okay. Good thus far? And let's get caffeine there. It's a good place for caffeine. I haven't shown anything crazy. This all should be pretty comfortable. Let's get amped up to the next session. Ready, set, go. So we talked about lists briefly, right? lists are sequences of things, right? It doesn't really matter what's in there. The sequence is mutable, which means you can add things to it, you can take things off, you can change it, you can change the elements. So let's do that. So scroll down to where it says voltage list. And let's make some, execute the first one, execute the next one, so we see that it is indeed type list. Everyone with me? Everyone, the one that came in late? Confused about which notebook we're in? Okay. So lists are sequences, which means you can ask what's the second element, what's the first element. So let's print voltage list, and then let's also print the first element. Everyone with me? So you can see that you can just print, you can get whatever's in the second one. We can change them. Voltage list of 0 equals IMOM. Right, let's change it to something completely different. And print it back. Voltage list. And it changes, right? Again, links are super flexible. You can stuff anything. You can reference index lists backwards. So if you want the last one, you can ask for the last one. Current list. Current list. You can ask for the second to last. That also works. Good. You can slice them, which means you can take only a piece of them. So let's grab the first to the third. So you'll see something interesting about the way Python does indexing is that it uses what's called a half-open range. So if you look at this, let's start with 0 to make it super easy. So the 0th element is in the slice, and the 1, and the 2nd, and the 3rd is excluded, which is very C-like, not MATLAB-like. I'm not sure what R does. Anyone know what R does? Well, so R is 0-based, but does it do the half-open thing? Is the last index included? Okay. So there's that. This is a little convenient because you can add lists together. So it makes the notation a little simpler in this context. So the third element is excluded, but then it's included when you start from the line. So you can slice a list into 2 pieces, concatenate them back, without doing any plus or minus 1 index. Which is convenient. It's maybe a little different than you've done. It is what it is. Sorry. R includes it. Okay. And the one last thing is if you neglect, so you have 3 colon, it goes to the end because I didn't tell it where to stop. Likewise, I can go just to the 3rd and it starts at 0. Okay. So then links of lists. We can put different things in there. We can make lists of lists. Right. So if you look at this example under endogenous data, you can have the data list. It has a string, and a string, and an int, and a string, float, and a string, and another list. And it lists, a list, a list, a list, a list, a lists. So super flexible. Let's talk about files. So Python has what are called tuples. A tuple, for the extent you guys care about, it's a list that you can't modify. It is fixed size. You can't append to it. You can't take things off. It's useful in working with dictionaries, which I'll talk about. But for all you care about, a tuple is a list that you can't change. Okay? And if you try to change it to 0 is 3, it'll yell at you. Tuple object does not support item assignment because you can't change it. It's tuple. Okay? We're going to skip sets. Let's do dictionaries. Dictionaries are fun. So all of you are sort of familiar with lists, right? We use lists and arrays everywhere. You should be pretty familiar. You may not have spent as much time with dictionaries, which may be called associative arrays. They may be called maps. They may be called hashes, depending on where you're coming from. And so the idea of a dictionary is that you have a sequence of key value pairs. So you have one sequence that's all the keys, and you have another sequence that's all the values for that. And keys can be anything so long as it's immutable. So let's first make one, and then we'll play with it. So execute this data dict. Now, I don't see a lot of enters. And here's some clicking. And we can print a data dict. And you can see that you have a key of experiment with a value that's a string. And another string int, string float, string list, string list. So there's no obligation for the keys or the values to be of any particular type. You can reference these by key. Right? So what this is doing is it's saying, I have this data dictionary, and I'm giving saying, I have the key experiment. Go find the value for that. Yeah?
You also have the list. You have a list of people.
So a list is just a sequence. There's no sense, there's no two sequences of things. It's just a sequence.
No, you have a dictionary.
No. You can have a dictionary with a tuple as a key. And so the reason here is right. So the reason is the key needs to be immutable so that I can always find the key. Right? So if the key is allowed to change, so you start up with a single list, with a particular list, and then you modify the list, what is the right way to look it up? Do I look it up by the original value of the list? Do I look it up by the value I changed it to? What's the right thing to do? And it's ambiguous. And so we just disallow it entirely. And so, but instead, if I wanted to say data dict, so I can't say list 1, 2, 3, but I can say tuple 1, 2, 3. So note that lists use brackets to note sequence, and tuples use parens. If you have a tuple of one element, you write it like that. You have to give it the comma. So we can give data dicts key of 1, 2, 3, and assign it your favorite integer, which of course is 42, and then we can print it, and where is it? It's right here. So the cool thing about dictionaries is they have different lookup complexity than lists. So if you have a list and you want to know a particular number is in the list, you have to step through every element in the list if it's unordered. Or if it is ordered, you search through it until you find something that's bigger and stop. Or do a binary search or some such. Dictionaries are super cool in that however long the dictionary is, it takes the same amount of time to look up a value. So you could have a gajillion length dictionary, and finding the value, and looking up the key, looking up a particular key always takes the same amount of time, which is really handy if you have something that needs the sort of performance requirements, right? I'm trying to think of a good example. Usually I use dictionaries because I find the interface more convenient. That I don't want that my data makes more sense being stored by a key. Like this could be so I use them in plotting where I want to name a particular callback function. This is not helpful. You have a good example top of your head? Ready, set, go. Word counts? Yeah. So you have a dictionary where the keys are words, and you want to know how many times that word is stored, right? So you're keeping a tally. You're doing spam filtering, and every time you see Viagra, you want to keep track of that because that's probably spam. And so in this case, even though you're going to have a huge number of words, it takes the same amount of time to look up a key, which is super helpful.
How is the ability sorted? I mean, I know
how is it sorted?
When you print it, it's a different sequence.
So dictionaries are unsorted. You can never guarantee the order of keys or values in a dictionary. That's the cost of the cheap access. Because what's happening under the hood is you compute what's called a hash of the key, and then you use that hash to do quick lookups. Basically, you have an array of the values, and you compute the hash, which tells you which index in that array. Is sort of what's going on with the hood. But dictionaries are unordered. Do not count on them having a specific order. So, cool thing about dictionaries, let's that makes sense. Let's talk about, this is where I want. So you can ask a dictionary what its keys are. Let's scroll down to the very bottom. You can ask a dictionary what its keys are, right? Remember from data dict print it. So run temperature current, run temperature height of that strange 1, 2, 3. Right, so you can see all the keys. You can ask it for its values, and these, again, are going to be unsorted. These are going to be in whatever order the computer decides they want to be. Don't count on them having a particular. They can get shuffled if you add elements to a dictionary. Right? You can add data dict of new key. Do that. Totally. Questions about dictionaries? They're kind of weird. Brains fried? Yes.
If all these variables are not the same type, for example, one set and the other one. Say that fetch the values of the to it. But now that we have multiple types, or if we have a special dictionary that all the keys are here, let me just put it by arranged.
Right. So the question is, are dictionaries sliceable? Those really questions. Right. So you have a dictionary and it has a bunch of keys, and the keys are integers 1 through 10. So in my brain, I think, okay, I have keys that look like they should be sorted, like should have some sort of order. Can I say, give me all the keys between 3 and 10? And the answer is no. And it comes back to this idea that a dictionary doesn't, the dictionary only knows about the hash of a particular key. It doesn't actually know what the value is. And so this hash function is basically a random number generator as far as you're concerned. And so the hashes that come out of 1 through 10 can be whatever crazy order they want. Additionally, again, dicts are unordered. And so there is no notion of an order to slice from. So, yeah. Key can be a string. So types in Python that are immutable. Numbers are immutable, right? Ints, floats, complex numbers. Tuples are immutable. Strings are immutable. I think that's it. And you can build tuples in different combinations of these, which will also work. So if I wanted to make key 1, 3.4 in the list 4, that's, oh, it's unhashable, right? I can't do that. I have to put this another tuple. Right? So if you see this error unhashable, it means dictionaries are, you can't feed mutable things. It doesn't know how to compute a hash of list. And so that's what it's yelling at you about. Good. Can we move on to iteration and looping? Good. Guys are troopers. So open up Python flow control. So let's do conditionals first. So this introduces the topic of white space in Python. In Python, white space is significant. Let me repeat that. White space is significant. How your file is indented matters. Which is odd. For many languages, it's become more popular these days, but it matters. And the reason for this is most people indent their code anyways, and there's actual meaning in that. It really helps to read something. And an if statement is always indented. That way, when you scan through the code, you can very quickly see, well, this is a loop, this is an if statement, here's a while. I know all of these things, and I know that the statements in this indented block correspond to this if statement. And so you don't have to do weird things trying to parse semicolons or chase the brace or yell at your coworker that indents strangely. So Python has the sort of the philosophy that there's one right way to do it, preferably only one. And so it enforces this by having a preferred syntax to its blocks. Rather, of making white space significant. So hopefully you have the Python flow control notebook open. Have I lost anyone yet? Okay. And how about you just beat on the conditional section? So just go through and evaluate these first couple things. Ask if things are greater than each other or less than. So the convention, so I will say this, the convention in Python is that indentation is 4 spaces. In the notebook, it'll auto-indent for you once you're in a block, which is nice. Please use 4. It just makes everything simpler. You can tab, and it will go 4. So Let's execute these four.
What's the oh, yeah.
Okay, so we see from this first one, the syntax for an if statement is you have the keyword if, you have some expression that will evaluate to a true or a false, and then a colon delimits the start of an if block, and then you have a bunch of indented statements that will execute only if this expression evaluates to true. Right, and so less than works like you'd expect. Else is spelled else. Python has elif, which is spelled elif. Right, so this is if the first one doesn't pass, else. If this one does, then this. And then else is, of course, the catch-all. Right, Python doesn't know what that means. You can compare things that are not alike. True is not equal to the string true. Some language will do that coercion for you. But as an odd sort of corner case, false actually is 0. So Python, if this means something to you, Python is optimistic when it comes to comparisons. If something is not 0, then it is assumed to be true. That makes sense. So if you say if 3, that's true. If you say if 0, that's false. If you say if -1, that's true. There's a question? Oh, I lost it. Yeah.
There are ifs inside of this.
Yep. So, if true, if 1 is greater than 2, print, right, else. This? Is that what your question is?
Yeah. I have like that for S.
Okay, so the question is, let's say you have this structure, right? You have an if with an else, and then you have a nested if with an else inside. And so in this particular case, it's pretty clear what should happen, right? That if the first one evaluates to false, then you come down here. The first evaluates to true, you evaluate the second, and then you get this. But this is perhaps more ambiguous, right? And so the answer is the indentation tells you. So in this case, if true, we'll jump to else. And if true, and if there's no alternate condition, it just continues in the rest of this block, right? You could have foo equals 17, and it would just continue on its merry way. So in this case, it's not ambiguous again, or rather, it's not misleading. And the answer is the indentation tells you which part of which block here. Yeah. Okay. So, more getting into control flow. Remember we had lists? Remember lists? Haven't forgot about them yet? Still good? You can test whether an object is in a list. So what this will basically do is, so we've made this variable beetle equals John, and we've made a list of beetles, and then we can ask if beetle, right? We can ask if John is in this sequence. Likewise, we can ask Matt, because Matt's giving the presentation. Matt is not in the beetles. Sorry. You can ask, the keyword not does what you think it should, but Matt is definitely not in the Beatles. They didn't have any baritones, so that'd be really weird. I guess I can play the drums. Ringo didn't sing too much. So we can also we can do similar things. Let's make a dictionary. My dictionary. 1, 1, 2, 2, 3. Sorry, my syntax is wrong here. There we go. So defining dictionaries has the syntax key colon value, comma, the next element key colon value, comma, key colon value. So we can make a dictionary. We can ask, is 1 in my dictionary? It is. So we can ask if keys are in dictionaries. We could ask if 1 is in keys. Right? So keys, remember, gives you the list of keys that are in a dictionary. We can ask if it's in the values, but it's not. Remember, values are the strings in this case. Yeah? So in is super useful. It makes your code very concise, very clear what's going on. So let's review. What have we introduced in the last 7 minutes? We've given you if statements. Right, so we have if, and else, and elif. I've shown you that Python has booleans, so true and also false. Those are first class. Python has all of the comparison things you'd expect. You have less than, greater than, less than equal, greater equal, double equals for doing comparison, and not equal. Right? All these should be familiar. We've introduced in and not in. So you can ask whether an element is in a sequence, and that's meaningful. We can ask if a key is in a dictionary. Good? Good? So let's do iteration now.
By the way,
Yeah.
single quotes and double quotes are exactly the same.
Single quotes and double quotes are exactly the same. The one place where they make a difference is if you have a long string that is, hi, my name is Matt. Okay? So if you have a situation where the string ought to have quotes, right? You should use the other ones on the outside. Right? So that's fine. Print do long string. There's also hi, my name is double Matt, double bang, string. Okay? Single quotes, double quotes are all the same. I like singles, whatever. Do what you like. But they're super handy if you actually need quotes in your string. Indentation. White space is significant. So let's do this short exercise. So look where it says short exercise. Click this insert cell below button. Type in your answer. So, probably came up with something that looks a little like this. X equals 3, and you probably tried to do some integer arithmetic. Maybe you got lucky and asked if Python has a div mod function, which will give you the integer division and integer remainder. You come up with something like this. Hopefully you got the if and else under control, right? Got the indentation is not so scary. Good to go? Yeah.
The only thing that matters is indentation. It doesn't matter whether it's one state, this just check that.
Yeah.
This tab does work. Just with one state.
Yep. It's true. The actual size of the space doesn't matter. But please use 4. Just please use 4. And please always use 4. It makes it so much easier reading your code. It's not a big deal. If you know how to configure your editor, just make it do 4 for tab. Not. Yeah.
I've had a lot of, like, white space.
Okay. Sure.
And, I mean, is there one that, like a lot of times I'll use, like, script, right? It'll, like, yeah.
Okay.
It'll, like, tab, whatever. And I just,
So specifically with Python or just in general? Oftentimes that has to do with mixing tabs and spaces. Both of which are legal but can make it really hard to interpret what's going on. So you should pick one or the other and only use one. Yeah, return's fine. There's also sometimes if you're trading files between Windows and Linux and Mac, nobody agrees on the correct way to denote a new line. And that's sort of not Python's fault. I haven't had too many problems with that, but sometimes it shows up. And in those cases, you have to use something like DOS to Unix. I'm not sure what the equivalent is on PC. But there are programs that will look at a file and see how new lines are delimited, whether they're, there's carriage return line feed is how Windows does it. And Linux does line feed, and Mac does character or something. I'm sorry. It is what it is. Okay. Yeah, you had a question?
Good question. Actually, a little different way, but I suspect
Yep.
it's like every time.
So you said, you're saying type of I of x divided by 2 is equal to int.
Yeah.
Trying to that's always not. Yeah. Okay.
So if you divide integer arithmetic produces integers. So this is actually a good thing. This is a great question. If you print 3 divided by 2, so let's do super simple. 1 divided by 2. 0. They fixed this in Python 3. It's really obnoxious right now. But
It's not because I think seek and it's
right. So what's going on is Python looks at 1 and 2 and says they're integers. I know how to do integer arithmetic, which is different than floating point arithmetic, and gives you back an integer answer. This is how things work in C. And it's an unfortunate historical accident. This is the wrong answer. Right? This is the wrong answer. This is a ward. And so in the future, in Python 3, this is fixed. But for Python 2.7, which is what we're teaching you, it is what it is. And so you're stuck doing this hack.
just because that.
Right. But if say 1 was a variable, right, if this was 1 divided by 2, and I don't know what those are going to be. So 1 is 1, 2 is 2, then I have to do it this way. I'm sorry, it's a word. Good with this? Okay, let's do loops. So, we have these sequences. We want to be able to loop over, right? We want to step through each element in a sequence and do something. Because otherwise, we're not really saving ourselves anywhere. We want to be able to automate processes. And so, in Python, let's look at this fruit slide. Look at this one. So, execute the first one. Execute the second. So, what'll happen when you iterate through a sequence? No, this is the right way. So Python has both for and while loops. Some languages have taken the step to get rid of while entirely, but Python has both for and while loops. So in a while loop, which you've probably all written and seen, you denote a while block with while and then some condition. And this condition will get executed every time. And then you have some block that gets executed if this while statement evaluates to true. And so you print through and you start up with I equals to 0, so we're going to index in fruits. And you print the ith element, starts out to 0, then you increment, and while I is less than fruits, less than the length of fruits, continues. Okay? There are there are two great problems in computer science. There's cache invalidation. There's what do we name things, and there's off by 1 errors. Right? So this particular case, this sort of error that I get the length of the array off by 1 because I'm not paying attention. And I wasn't sure. Python does this funny thing with indexing, and I'm not sure if I should start at 0 or 1, right? If I started off like that, it would do similar things. Or if I put I equals I plus 1 up here instead of down here, that would cause an off by 1 error, right? There's a whole bunch of ways that these while loops can cause bugs and cause problems. And so while Python has them, there is a more convenient way to iterate over sequences. So, which is very, what did I do? Equals, yeah. Which is very cleverly in the next cell. And that is, you can iterate directly over a sequence. So, I'm going to give you an exercise. So, you see this for fruit and fruits, right? Write a loop that iterates over the first 3 elements of the same fruits list. So, write a loop that iterates for first 3 elements. That should be apples, oranges, bananas. Where do you say go? Give me a green sticker when you come. Hopefully you remembered our list slicing syntax. So I can say for the first 3 elements in list, loop through them and print. Super easy, right? Not too much syntax, no semicolons to forget, just this white space oddity. So another thing to notice with the list indexing slicing syntax is that if you do it in this form from colon to 3, that means your list will have 3 elements. A list will always have first index, last index minus first index elements. So this is implicitly 3 minus 0 is 3 elements. 1 to 3 would be 3 minus 1 is 2 elements, which is handy. So let's do. We've got here the one that says 19. So a dictionary should be iterable, right? They're sequences. You should be able to walk through those. So let's execute this. So first delete this. So just do for fruit and prices, print fruit. I'll make you type this. And I'm going to make you type it back in so it's in your fingers. It's important that your coding is in your fingers and not in your brain, because your brain's stupid, but your fingers are smart. Right, so what's going on? For fruit and prices, let's look up at prices. So it has keys that are names of different fruits, and then it has prices. I guess that's per pound or something. And you see that when you iterate through prices, right, which is a dictionary. Remember dictionaries? They do this key value funny thing. What it's doing is giving you the keys. Right, so this is the same as this. Yeah? Now, sometimes we might want both pieces, right? We could, of course, do prices of fruit, right? If we wanted the values too, right? What is this going to do? Somebody? Right. It'll print the values. But that's kind of obnoxious, right? There's way too much typing. What I really want is something that looks like this. Print fruit. I can't type fruit. My brain is a little fried too. And so what's going on here is that prices.items returns a sequence of fruit price tuples, which then get conveniently unpacked for you. And so if you were to say, what is prices.items, the first element, it's a tuple where the first element is prices and the second is the price. And so by iterating through prices.items, which fruit boost is a list of these things, you can unpack each of those into fruit price. Right? Yeah.
So comment when using a statement, is that some explanation?
So this, if I was to write it like this, that looks like a tuple, right?
No, that's not my question. My question is following print statement.
Yep.
Comma space price.
Yes.
What
is that?
Yeah, it looks as though that's printing it out as just a simple space. So is that in the out of the statement separated by concatenate elements together? So space between these things.
So print will always introduce a space. This is different from this. Right? So this is printing a tuple that is fruit prices. And this is just printing two things, where the first is fruit and prices. So the way print works is it's a language level construct that you give it as many arguments as you want that are common to limit. And then it'll print one, give you space, print the next, give you space, until you run out of. Yep. So let's do one last thing. So just to recap, we've talked about iteration, right? We have lists and you have dictionaries. These are sequences. We can iterate over them, which has this, you can have a for loop that goes for element in sequence, which makes it a very convenient way to step through all of the elements in a particular sequence. It gets rid of the issue of trying to index directly into the sequences because you will have an off by one error. And those are super common. There's been a lot of software development studies that show that those are super common and super prevalent. And any sort of language level things you can have that make those go away significantly increases code quality. So, and it prevents the amount of typing we have to write. The less I have to think, the better. So we can iterate over things. We can iterate over dictionaries. We can iterate over lists. You can iterate over tuples just the same way. Python has I didn't say this, there's look at range and zip. We showed you while loops. And while they're handy, they're a little clunky. So for is probably a better idea. And we've done some stuff with comparison of integers. So let's do one last thing. We'll just go way down. Just scroll to the end and let's get a new. Because you guys haven't seen functions. So I'm going to do these quickly and then I'm going to plot pictures and you don't have to type. So Python has functions. Functions are awesome, right? You get to put stuff in a form that you can reuse it. The syntax for defining a function is super complicated. It's def func name. Give it x and y. Print x, y. So let's look at the structure of this. You have a def keyword that says, I'm starting a function definition. You have the name of the function, which in this case is func name. And then you have a list of arguments. So in this case, x and y. And then you have the actual body of the function is indented. Print x plus y, say z equals x plus y. And you can return a value. Okay? So we can call it name 1, 2. So why don't all of you type this out? Just again, get it in your fingers. Fingers are smart. Everyone can see this. This isn't too small. Okay. Alright, looks like most of you have this under control. Any issues? Give me a red sticker if you're not done. Okay. So, in addition to normal arguments, you can also have optional arguments, also called keyword arguments, to functions. And so what these do, print optional. Right? And since I called func name with argument 1, comma, second argument, and I didn't tell it anything about optional, it just used the default value, which is optional. Likewise, I can optional equals I can give it a value, and that works like you'd expect. Again, nothing crazy. In terms of defining, I'm working on code basics. It's often good to, like keyword arguments are really useful for adding functionality after your function is defined works. Since they're optional, you can retain the existing way things worked, and then just start tacking on additional functionality, optional functionality, retain backwards compatibility, super convenient. If you forget to return a value, Python will return none. So assign this to a variable var, print var. It will by default return none if you don't return anything else. So if you see this show up, that you've written a big script and you have logic like if x is greater than y, return true. You can get into this weird situation where it used to return true, but now it returns none. So if you see that, it means you probably just missed something and you're getting the default return value.
Your variable name not the
So yes.
you don't have any my.
Right. So scoping rules in functions. You can can see into the outside world. Right, you can see into the outside world. If x was equal to, I haven't heard any good jokes. It gets the right one. You pass it an argument in. It uses the one in the local scope. You cannot change global fish equals 19. This will yell at you. You can't change global scope. You can. There was ways to get around that, but in general, it's bad practice. And so it won't let you do it. It'll let you see out, but you can't change. Look, but don't touch. Right? Great question. Thank you. Yes.
So maybe I
So can you return several values is the question. Yes, you can. So I can return true and 3. Oh, get rid of this global-ish. I can return a tuple, which the parentheses are optional. But I can return this. So I've just put, so in this return line, just get rid of this whole. Just, return Z plus. That's allowed. And you can unpack it on the other side. Okay? Does that make sense? You can return anywhere you want. Also a great question. Brains melted? Okay. I'll show you some pretty pictures. So, if you want to follow along, I will very crudely, let's just do it. A new notebook. So Python has a library. So it's not part of the standard library, but it's very widely used in computing called Matplotlib. That's handy for making plots. So I'm showing you another bit of syntax. When you import something, you can change its name. So typing matplotlib.pyplot is really obnoxious. I'd really like to just call it PLT long line. Likewise, there's an array library called NumPy, which I'm going to call P. And IPython has what's called a magic function. This is not part of Python proper, but this is IPython that makes interactive graphics easier. So let's plot 1, 2, 3, everyone's favorite plot. So simple plots are pretty simple. If we look at this PLT namespace, we can see other things that are available. There's a whole bunch of stuff. There's still a whole bunch of stuff, right? Lots of features. So you just saw a line plot. If you're familiar with MATLAB, it uses MATLAB style formatting. So if I Right, so I can make the line color red. If I want circles, I can put circles. If line style, I can make the line style something like dashed. So you can't see the dashed lines because there's already a red line there. So if I make the red line green, it'll plot over top. That's probably not visible in fact. So we've got to start. Dotted line, circles, beautiful, right? You can do scatter plots. So NumPy has a random number generator. I want 20 points. So if you have 20 random numbers between 0 and 1, that random and 20, but the different 20 numbers, I can plot those. Oh, failing. All right, crazy squiggles. We can do scatter plots. Scatter plots, yeah. You all look very excited. I like pseudo color plots. So, X. So I'm just sort of going to show you the basics of things. There's a notebook with a better description, but it's 10 after 4. We let you go at 4:30. Just sit back and enjoy. If you have questions, like go nuts. If there's a particular kind of plot you would like to know about, we can make that here on the fly. This can be very interactive, and you're not obligated to actually do anything. So feel free. You can just watch me squirm up here. So go nuts. You can have pseudo color plots. So right, so if you have a 2D grid of numbers, because you just ran a two-dimensional simulation of something, and then you have an elevation number for each of those. So maybe you're doing GIS kind of stuff. You have latitudes and longitudes. You can plot. You can map those heights to a pseudo color map and plot that. So that's handy. You can add color bars. Color bars, beautiful. If you want change color map. There are a couple of those to find for you. There's bone, which is white to black, but kind of bluish. There's a bunch of others. So, get a clean version. There are image plots. Remember how to get plots. This is crap. Cat. Cool. Cat pictures. Everyone loves funny cat pictures, right? Oh, that's creepy. I'm sorry. Let's go with this one. That's one.
Put that on first page.
I know.
Cat pictures on Google. Seriously.
Someone is trolling us. Let's look at the image. Oh, it went away. Save image as. Put it. Use at. There. So we get an image. I can read. Use at. Notice all the tab completion. Second greatest thing ever. And then there's show, right? Because these are images, so we read it in. IMRead takes the path to a picture on your desktop somewhere and reads it in, gives you an array. And then IMShow plots it. Image. And there's our cute cat. You can zoom in. We're really excited about eyes. I don't know, maybe some of us are studying eyes. We can pan around. Save. Right? For all the things you want to see. So, these are some pretty basic plots. In real life, the way you make a plot is you go to the Matplotlib website and you go to their gallery and you look for something that looks vague. That. It's like a radar plot with bubbles of different sizes. That's pretty cool. And it gives you all of the code to make it. So let's copy this and see what's going on. Copy. Where am I going to go? Here it is. I paste it in. And plot it. Nope, there it is. Okay, so it works. This random source code I grabbed off the internet works. That's great. Right? That's how the life wants to be. So let's look at this particular plot that's going. Please, any questions? I'm just going to keep rambling. And you're going to be subjected to whatever I find amusing. Yes, great.
Can you write some codes for your Carpentry with tabular
Yes.
matrix?
Yeah, so actually NumPy, which we'll talk a little about tomorrow, has a function for doing just that, right? Because we often have cases where we have a comma delimiter or space delimited file with data in it. And I just want to put that in an array. And there's a function called...
Actually, we're going to look at that.
Okay, excellent. So we'll hit it. But there's gen from text, which is a NumPy function, which does. I don't have a canned example for it, but definitely exists.
But there will be no.
And tomorrow in testing, we'll hit that. So, yes. There's another question. Someone? Okay. Yes. So, like in Python to see what is everything that's defined, right? Is that the question? Yes. So Python has a built-in function called dir, dir, as a directory. What are all the locally defined variables? Right, so dir with no arguments. just gives you everything that's local, which is helpful. You can ask for, scroll back up, so this IMG thing with that cat picture, right? We can ask, what's an IMG? And it'll tell you all the functions, everything attached to it. There's a whole bunch of stuff. Yep. Which is, what does that do? Oh, that's nifty. So IPython, I didn't know this. I just learned this. IPython has a bunch of these convenience functions that are usually prefixed to the percent. There we go. That will do sort of magical things for inspecting your environment. And so there's one called whos, which tells you everything that's been defined and what its value is. Just super. Yes.
Could you talk a little bit about how you as a programmer, as a researcher, use Python?
Yes.
Because I get the impression that it's kind of a little hack. You have this function to kind of execute things or
yeah.
Does it typically kind of like if you're coding a job, maybe do some clips, large number of
Yep. So
equivalent kind of situation.
So I personally sort of work in two modes. So one mode is software development mode, which is I'm developing a library. And the other is data analysis, which is I have a data set that I'm trying to understand. I have some experimental data that I'm poking around and trying to understand. And so, and your needs for interactivity are different in both of those cases. Right? So if you're doing data analysis, I want to see my data now, I want to see my plots now, I don't want to wait. Like I want super convenience, even at the expense of not being terribly efficient or whatever, because I'm looking at things now and trying to understand. I want as little friction between understanding and doing. So in those cases, so as data analysis, I'm often in an IPython notebook with all these convenient bells and whistles, writing sort of one-off scripts to look at data, to do data analysis. And so in those cases, it's sort of okay to be a little fast and loose with things, like how you name things or exactly what's going on. And then sort of once you get to the right answer, I'll save the notebook and go back and clean it up. And use that as sort of the basis to present my work to my. When I'm operating as software developer, right? In this case, I'm working on a library that deals with a particular binary format that no one else uses, and so I'm working on that, and I'm writing analysis routines to work on biggish data sets, and I'm writing this as sort of infrastructure code, and I'm writing a library that I will use for doing data analysis later. But this is really infrastructure, or I'm working on a bigger project like Matplotlib or something. In those cases, I'm mostly doing all my development just in the straight-up text editor. I use Vim. I have a bunch of plugins to help with tab deletion and some such. But I'm basically in raw text editor. There are some, there's text editors like Sublime Text, which has some pretty good code completion and can actually parse Python as part of the code editor, so it's more sort of at the IDE level that it can help out with some of these things, and that kind of stuff. Is how I personally work. I will often have the way I would write something. What do I have? Time to pick up the carpool. So I've been working on helping out Matplotlib with their testing requirement. And so this is the repo that I've been banging on. And there's an install script here, which has 17 different ways to install Matplotlib. I think it's 13, but it's close. All on the Mac. It's more complicated than it should be. And so I will just full screen my text editor. Other people do different things, but you can see what I do. I will often split my screen so that I can look at different things, and then open different buffers. You can see the bottom. I'm giving it a path. I've got the Exodus, the access codes. And so I can look through here. There's documentation available. Python has internal doc strings. Look at the and bounce around the. I will often have another. I'll also be writing something like this while I write, where I'm writing a separate testing function. So I'm developing something that should accomplish something, and I have some way, and I know what it's supposed to do, and I can test against the correct behavior. And so I'm writing and also banging on my tests to make sure things. So in terms of environment, it looks like this. I'm sort of bouncing around. In this case, I'm in Matplotlib. I usually know where things are, so I know how to jump there. But that's how I work. Do what you like. Yeah.
You can add that I think there's also an intermediate stage for me. An intermediate stage, which is I have some data and I don't exactly know what I'm going to do with that, so I start exploring it. And while I'm exploring it, I end up writing functions that do things. And I do that in the notebook. I define a cell that is a function definition for plotting some feature of the data, calculating some of the data. And then when I'm happy with that, I take that entire cell and I copy it over into a buffer, which is now my library. And then I import that library into every time. From then on, I write some tests for that. And then I import that library, run the tests separately. So we'll see tomorrow how to test cases. And so I start with kind of trying things out pretty hackishly in the notebook, but I end up kind of extracting from that functions that are general.
So, yeah. So the question is, in the notebook, there's this little thing at the top that says autosave. What's going on with that? Where is that? Where is it saved? So you come back to where we started. Started the notebook server. And you do an ls-a. There is supposed to be right here. What's supposed to be right here? There's a
Hit the Control S.
Control S. Back here. So I don't know why it's not there, but usually it's a dot. There's a directory. So in the directory you started the notebook, IPython notebook will start a new create a new directory called it's like .ipython autosave or something. Checkpoints. And the files will be in there. That's where it's autosaving to. I'm not entirely sure why it's not here, but that's where we go.
But also notice that these files, these IPython files, those are the notebooks. But it's a text-based file format that has all the information that IPython needs to render the notebooks. And those can be, for example, those can be version controlled because they're text-based. You can get to track the changes you make in the note file, which is kind of.
So this is what a notebook actually looks like. I don't know off the top of my head.
No, it is. It's IPy.
Yeah, it's
The notebook format has coded inside those. It has like a complicated structure, but inside there's the Python.
Fine.
So the question is, if you save your files now, will they be available tomorrow, or should you, or how do you rely on the autosave to do that for you, or so. So the question is, I see this notebook thing is being rendered in the browser on this IP address thing. And so one thing I've learned about the internet is that it may or may not be there. And so that makes me really worried that I'm going to save this thing in this notebook thing that looks like it's in the web or in the browser or something, and I'm going to try and open it tomorrow, and it's going to be gone. Right? That's a reasonable question. And the answer is, the files are all saved locally. So they're actually, the notebook itself is this IPython flow control.ipynb. And if I save that file, it is saved to that file. Like if I save it in the browser, it saves to that file. That is the notebook. And there's this auto checkpointing thing that happens. But if you want something to be saved, you should save it. And so it will be there, and then you can open it. You can completely close the. And so let's give you a quick example. No, you would just say IPython space notebook in the correct directory, and then it'll show up. So
you have to invoke it from the directory, that file, that .ipy.
Right. So in this case, I have a notebook named Untitled 0, which is just the default. And then we look in the directory where the notebook is, and there's this Untitled 0 file. Right? Now I can close the notebook server. Gone, dead, dying. Okay, dead, gone. It's no longer running. And I can open a new one. Thinking an open Untitled 0, and there it is. This is the plotting notebook we were just working with in there. So it's the. So I think we're out of time.